Okay, let's set up the second part for homework 2. So for this, we're going to put forward to adding 2 workstation. One we call it special, for example, workstation. The other one is installation. Okay. So those are the 2 workstation we have, and then we adding the route in between. So after the parts leave the system from the incoming inspection station, uh, the screen goes through the special, and the electronic goes through the installation station. So I'm going to do some easy part. Okay, good. That's fairly easy. We just added it to the system, and then we can see that for this, the part A and B both come through the separator. After separator, the one on the top, we'll call the parent node, output node, is, we assume, is a screen. And they go to special, then come into the parents of a combiner. The one on the bottom for the separator, we assume they are electronic parts passing through the incoming inspection, go through the installation, go into the member portion of the input nodes on the combiner before it reaches the assembly. So we need to kind of adjust uh, the sequences for both parts a little bit. So here we go to the data, we define some of the uh, sequence table. For example, from incoming, go to assembly 2, assembly 1, and post assembly. So what I'm trying to do is, after they passing the incoming inspection, they can either go into uh, special for this screen part, then go to the parent nodes of the combiner. So we add these 2 steps into our uh, step. First, go into the uh, special workstation for that. Okay, and then goes to the uh, parent nodes of the combiner input. Okay, so that's what we basically have so far. And special nodes are for model A, supposed to be random per between 7 minutes to 16 minutes, most likely 11 minutes. And the combiner, we don't have any processing time. Okay, these are the things actually working out for me. And let's see how about sequence part B. We do the same thing. After is incoming inspection, we adding 2 more steps. One step is going to the special workstation, because both of those are uh, assumed to be screen, but it's just the model A and B difference. Okay, model A and B then goes to the member of combiner. So they're coming down to the member, this part. Okay, and the processing time for the special stations, random per A to 12 minutes, most likely 10 minutes, and so on and so forth. All right, and the part table stayed the same for that. Now we need to determine the sequences for the guys coming down here. So the electronic parts coming out of the member portion of the unpack station, member portion of unpack station, I'm sorry, I'm going to call this unpack. They're coming out of the member portion of the unpack station and go into the incoming inspection, go to installation, then go into combiner in the member portion. So let's see if we can establish something like that. So here I'm going to adding two more sequence table, adding sequence table, adding two more. This one we put a sequence model A electronic. How's that? And this one we're going to call it sequence model B electronic. Okay. For model A and the model B, basically they are the same, so we're kind of working out. So here we have, after it come out of the come out of a separator, it goes to the incoming inspection first, then goes to installation, then goes to the input member of the combiner A, member input of combiner A. Join. The other one is about the same. First, we go to the incoming inspection, then goes to the installation, then goes to the input model of combiner A. Okay. Also, we can adding some processing time associated with it. We're going to call this guy. Okay. We call it processing times. I'm going to change processing time. Make sure we change the unit type into time in minutes. What we have is the processing time over to those two workstations. For example, I do this real quick from my previous, from my another model, and this is actually copy from the homework assignments data. Same thing for the electronic model B. Create expression column called the processing time. Change the unit type to time. Okay, so these are the processing time for this section. Okay, and then adding these two sequences is done. We can actually add these two sequence table into our part table. So this is number 3, for example, number 4, adding model A electronics, model B electronics, and the processing time is exactly the same. Supposed to be sequence model A electronics, sorry, dot processing time. Okay, and this part will be sequence model B electronics processing time. Exactly the same as before, so we can see that. Okay, move this table a little bit over to the back, so you will see sequence for model A screen, sequence for model B screen, sequence for model A electronics, sequence for model B electronics, and the part table. I'm just going to copy the data for, now we have 4 sequences. We can change these from these table array directly embedded into the sequence table. So let's do that. You can do both, keep the table, but this should be fine. Okay, here's B. And this model A screen supposed to be able to do that. Model A screen supposed to be replaced by this. Model B screen actually supposed to be able to replace by that. So just to illustrate what is going on with this, okay, going on with this, so you can see how these things can be done. Now I can delete all these tables. We don't need them anymore because all these processing time being incorporated into the sequence table and the part table. Go back to the facility portion. After I've done this, I should have the screen, doesn't matter, coming up from the parent node of the unpack, going to incoming inspection, through the special, go to the parent nodes of the combiner. Then depends on which type of model it goes. Model A goes to assembly 2 first, then assembly 1. Then model B goes to assembly 1 first, then goes to assembly 2, then goes to post assembly inspection, then it goes to packing, shipping, then leave the system. So we don't have too much of differences. And look at the the electronics portion. The part get generated on the unpack station, coming out from the member nodes and going to incoming inspection, installation, going to the combiner A's member input node, then disappear because you combine with the electronics. So we have a longer processing sequence table for the screen, which we represent the main entity, and the electronics have a short lifespan. The question we have right here is how do we actually so initially the model A, model B actually have their corresponding sequence, okay, corresponding sequence. So set already. All right. So we have a set already, and now how do we change them during this part being generated? So we learned this in the class already, what to do actually, and we can actually okay, now we're trying to set right after we leave this, we're going to change their sequence table. So we're going to be using the similar add-on process we have for that. Only in the member exit we need to change the sequence table on the fly, and for the parents portion we assume they are screened, so that's what we actually. So here we're just adding a unpack station when the member exit. Okay, So here, what we do is we have first a decide button. Okay, decide if it's model A or model B. So this guy is based on if entity is model A, for example. Or you can say part type, model type, model entity, model type equals 1. Okay, so we can do both ways. Then go to this direction. If it's model B, goes that direction. So we need to set them differently. Again, like we said, we're going to using the set row, which we did a couple times already. We're going to set row for the part table to row number 3. Row number 3 and the part table actually represents the sequence. Okay. Call the sequence table. Okay. Sequence table. And then over here in the sequence table, which is we have electronics in that section. So sequence model A electronic, we need to set them to the first stage. So here what we have also over here and over this direction, we're going to make a copy if it's model B. So we're going to set part table equals to 4. Then we're going to do one more of these. Set the sequence part table. Sorry, this guy. The sequence part table. Sequence table equals to step number 1. Okay. Make a copy for this. Okay. So if it's model A, we set it to part table equals to 3. Then based on that sequence table, we set it is equal to step number 1, and so on and so forth. Okay, that's pretty much give us the capability to run through the system. So one more time, let's review the process. After come out of packing, unpack, the original entity come out of parent node, goes through an incoming inspection. We assume their screen, then go to special, then go to unpack. After unpack, they go to go to combiner, then go to either assembly 2, assembly 1, then post inspection. So here, these 3 are now on the sequence. We need to specify their forwarding should follow by sequence. Okay, double check. The assembly output. Okay, this part also. And here, this is the trick we have for the post inspection. Instead of create another separate sequence, what we do, we're using the output node forwarding by the link weight to determine if it's trash. Then we're adding a dummy transfer node and forward them by sequence and so on and so forth. And this is the same thing. Let me see if this will work. Okay, we're ready to run this model. Let's see what happened. Okay, it looks like it's going through pretty good. And let's run it through. What happened? So all the sequence seems to work. Okay, and it is done. It's working. And let me double check. Oh, looks like we don't have any model B produced. Maybe the sequence have some error. And this is normal. We're just going back to check here. Okay, sequence B. Oh, find out. That should be the parent's input node, not the member input node. My bad. So we change that to sequence for model B and see if that will work. But just reduce the run length to 1 month from September 1st to October 1st and see what happens. So we don't have to wait here for too long. Okay, I have to change that. See if we, oh, yep, we produce both model. Okay, and we can see the result on the installation, and we have about 700 coming through the inspection. Let's look at the special workstation we add. The special workstation input buffer also have a 37 some 100 some entity passing through. So those actually confirm the reassignment of the sequence works pretty well. And since this example, we have separator create a short diverted sequence, and then the short diverted sequence for installation portion. It's very similar to the example we have introduced in the lectures, and it's just the diverting part is different. And on the unpack station member exit portion, we're adding a new add-on process. The add-on process actually decide model A and model B, set the corresponding things to the table, and then we can forward them and referring them into the data table right here to be processed. So these are the things actually we can use for manipulate. And for example, here we don't have additional sequence. I'm just using the by link weight, okay, by link weight, and set it to the repair when they come back, and then we the receiving node coming back from the repair actually has a forward by sequence. It's a little bit slightly different from the one we have in the lectures, but also this will work. I show you very different, several different ways to make it happen. So this particular portion, we just have to very careful where to forward the outcoming entity by sequence, or we're going to forward them by link weight, and same thing over here as the output of the post-assembly inspection. First, we're using by link weight to send the bad part in trash, and then we're adding a dummy node to forward the part by sequence. So these are the technique we can show you this time, and they are basically we have 4 different sequence table now, and they all incorporate with the proper processing time. Then we can actually delete these timing table since we already have a sequence to incorporate with them. So this concludes the sections of hint.